Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Plate with me, Richard here. Yes, today we are looking at this question. It says 12.5 grams of sodium hydroxide is dissolved in water to make 250 cubic decimeter of standard solution. Okay, 28 cubic centimeter of this solution is used to neutralize 15 cubic centimeter of sulfuric acid. And the question says calculate the concentration of standard solution. So when you look at the two reactants, we have sodium hydroxide and sulfuric acid. Which one is a standard solution? You have to remember that a standard solution is a solution of known concentration. So when you look at the two, the information we have for calculating standard is for sodium hydroxide. So sodium hydroxide is the standard. So what do we know about sodium hydroxide? First of all, we have to know that we are looking for concentration. We don't know it. Okay? What do we know? We know the mass. The mass is 12.5 grams. What else do we know? We know the volume. The volume is 250 cubic centimeter. And we convert it to cubic decimeter by dividing with 1,000. So what do we get here? 0.25 cubic decimeter. Okay. So that is the thing. Then we come to the formula. What's the formula? The formula involving mass is C, which is equal to mass over molar mass times V. So when you look at this data, we are missing something. What are we missing? Molar mass. The molar mass of sodium hydroxide. Okay. So what do we get? We have it. Sodium is 23 plus oxygen, which is 16 plus hydrogen, which is 1, giving you 40. Okay, so the information we have is now enough to use. So what do? We come and substitute. You say concentration is equal to mass, which is 12.5. Okay, divided by molar mass, which is 40, times volume, which is 0.25. What you get there is going to be the concentration of sodium hydroxide in moles per cubic decimeter. So that is it. So we have it here. The concentration of our standard is 1.25 moles per cubic decimeter. Yeah. Then comes this question. It says, calculate the concentration of sulfuric acid. Okay. Yes, how do you go about that? Okay, you have to know that when a case like this one comes, we move from known to unknown. Our unknown is sulfuric acid. So what do we do? The first step is to calculate the number of moles of sodium hydroxide reacting. That is the known, the standard. So this is always the first step. You move from known to unknown. So let us check what we know about sodium hydroxide. Okay. What do we know? This is what we know about sodium hydroxide. We calculated concentration, which was 1.25 moles per cubic decimeter. Okay. Then what else do we know? We know the volume of sodium hydroxide which is reacting, it is 28 cubic centimeter. Converting it to cubic decimeter, we divide by 1000, giving you 0.028 cubic decimeter. Okay, now we are looking for number of moles. So that's the information we have. So what do we do with this information? You calculate using the formula. The formula is C equaling to number of moles of our volume. Okay, our C is 1.25 and our N is wanted, but we know V, which is 0.028. So from here you have your N as 1.25 times 0.028, giving you, so that is it. So after getting number of moles, because what we have here are the number of moles of sodium hydroxide which reacted. After getting number of moles, we are now going to go ahead and find number of moles of sulfuric acid which reacted. And how do you do that? The link is through mole ratio, which we get through equation. The equation we are having is sodium hydroxide plus sulfuric acid, giving you sodium sulfate. You have to know that the valence of sulfate is 2 and sodium is 1. So in exchange of valences, we get this, plus water. After getting this one, what do? We go ahead and balance. Okay. So in balancing, what do? You have to remember that you have 2 sodium here, so you put it 2 here. When you do that, then you are going to have hydrogen, so you put it 2 there. Now the equation is balancing. What do we get from the mole ratio? What do we get from the equation? We get the mole ratio. So it's going to be 2 to 1. Okay. And I need to remind you that here we use only moles, nothing else. No concentration, not mass. And we already know the number of moles of sodium hydroxide which reacted. So you put it under sodium hydroxide. Okay. Then you look for this. And you have to know that these are directly proportional ratios. What does that mean? That you obtain the unknown through cross multiplication. So what are you going to get? You have 2x giving you 0.035. Okay. So this means that x is going to be 0.035 over 2. So there we are. So we have them. What are these? These are the number of moles of sulfuric acid which reacted. Okay. But the question wants concentration. So under this circumstance, what do you do? What you do, you list everything you know about sulfuric acid. So you say sulfuric acid. What do we know? Okay. We know the number of moles which reacted. We know N. And the N is 0.0175 moles. Okay. What is it doing about sulfuric acid? We didn't know the volume which reacted. The volume is 15 cubic centimeter. Okay, if you convert it to cubic decimeter, you divide by 1000 to give you 0.015 cubic decimeter. Okay, and we are looking for concentration. So from this information, the formula is very clearly known. The formula is C is equal to number of moles over volume. And what is number of moles? 0.0175. And what is the volume? 0.015. So what you get out of this is going to be our concentration in moles per cubic decimeter. So there we are. What we have here is the concentration of sulfuric acid, which is 1.17 moles per cubic decimeter. Yes. So then comes this question. It says, state the suitable indicator for this titration and explain your answer. Okay. How do you assess the indicator to be used? Okay, you have to know that what we are observing here is a reaction between sodium hydroxide and sulfuric acid. Okay. Then this is the base. Sodium hydroxide is the base, but is it strong or weak base? The answer is a strong base. Okay, this is the acid, sulfuric acid. Is it weak or strong? It's a strong. So we're observing a strong base reacting with a strong acid. So what is the pH attained if you are reacting a strong base with a strong acid? The pH is neutral. Okay. So what is the best indicator to work in the neutral condition? We said, the best indicator is bromothymol blue. Like I said previously, we use blue because water is indicated as blue and water is neutral. So we use blue to remember that it's bromothymal blue works in the neutral condition. Okay, what's the reason for choosing bromothymal blue? The reason is that the reaction is between a strong acid and a strong base. So that is it. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, we urge you to subscribe, to comment, to like, to share. And we need also to remind you that Physical Sciences Silver Bullet deals with Physical Sciences grade 12, 11, and 10, and Natural Sciences grade 8 and 9. We advise you that if you are using the channel, please use the playlist. Don't go to video. Just go to playlist and click the material which belongs to your level. For grade 8 and 9, choose Natural Sciences grade 8 or Natural Sciences grade 9. For grade 11 and 10, choose Physical Sciences grade 11 or Physical Sciences grade 10. As for grade 12, each chapter is presented independently, so just look for it, and then you'll have all the material which belongs to that chapter. We thank you. We love you. See you next time. Bye-bye.